Now let us discuss centroid of lines. So these are the different formulas we will be using for centroid of lines. So these are the formulas. So here shape is drawn and this is the length of the line and this is the x centroid and it is y centroid. Now for the first one, so there is a horizontal straight line and the length of the line is, let us say, small a. Now let this is x-axis and this is y-axis. Now let the length of the line L equal to a. Then we know the center of the line will be at exactly half of the line distance. So a by 2, that is half of the length, half of the a will gives the x centroid. Whereas y bar is 0 because there is no any dimension along y axis. Now the second one, that is there is a vertical straight line. Let this is x axis and this is y axis. The length of the line, that is the side of the line, is, let us say, a. Then we know the total length of the line as a, this is a. Then x bar means along x axis there is no any dimension, so x bar will be 0. Then y bar means it is up to the center of the line. So you can see in the diagram, this distance is y bar. So this y bar is exactly half of the line A. Similarly, in the first diagram also, you can see the distance x bar. So this x bar is exactly half of the line. So I have written a by 2. Similarly, in the second diagram, this y bar is a by 2 along vertical. So it is a by 2. Now let us see the third one, that is inclined straight line. You can see here. So the length of the line is, let us say, a and its angle is theta. So let the center of the line is a. Then we can see the distances, that is x bar. So this length gives x bar, means this is the side a. So up to here this is a by 2. You can see in the diagram. This length is a by 2 and the remaining length is also a by 2. So total length of the line is a. Up to center it is half of the line a by 2 and this is a by 2. Now this x bar is exactly equal to a by 2 cos theta. Then this length y bar is exactly equal to a by 2 sin theta. Now let us see the fourth one. So this is the arc of circle. So let this is the radius r. Let C is the center and this angle is alpha and this is also alpha. Now this is a arc of the circle. This is the line which is shown with a black color, indicates arc of circle. Now the total length of this arc is 2 alpha r. So this is the formula to calculate the length of this arc. Now its x bar means up to this, the distance up to center, that is x bar is r sin alpha by alpha. So whereas y bar is equal to 0 because the x axis and the center of this figure are at the same point, so y bar becomes 0. Now the next formula, so it is a semicircular arc, so which is drawn with a black color. You can see in the diagram. Let this is x-axis and this is the y-axis. So this is the semicircular arc. Now the formula to calculate the total length of the semicircular arc is pi r. Now x bar is the distance up to the center. So this length is x bar. Now the formula for the x bar is 2r by pi. Now y bar, that is y centroid, is 0 because the center x-axis both are at the same point. So there is no any distance along y, so it becomes 0. Now the next one, the last one, that is quarter circular arc. So the arc which is shown with a black color indicates quarter circular arc. Now let this point is the C. Let us say C is the center of the arc. Now the length of this quarter circular arc L equal to pi r by 2. So this is the formula to calculate length of the quarter circular arc. Then the x centroid, y centroid formulas. So this distance is x bar. The formula to calculate x bar is 2r by pi, and this is the length which will indicates the y centroid. We call it as a y bar. So that is also 2r by pi. So for the quarter circle, both x bar, y bar, both are same. So 2r by pi, and it is easy to remember also. Now let us take a centroid problem on lines. So this is the given problem. I'll read it. A slender homogeneous wire of uniform cross section is bent into the shape as shown in figure. Determine the coordinates of its centroid for the figure shown below. So this is the given problem, given diagram. So there is a vertical straight line, and this is the semicircular arc. It is also line. Then there is an inclined straight line. So we can see here wire is given. Wire means it is in the form of a line only. So that wire is bent into the shape given in the problem. Now we have to calculate the centroid of this figure. Now first let us see the given data. So here the total length of the line given as 6 centimeters. Then the radius of this semicircle given as 4 centimeters. The length of this inclined line given as 8 centimeters, and its angle is 30 degrees. Now let us take the horizontal line as a x-axis, and let us take the y-axis from the center of semicircle. So this y-axis we can take at this point, we can select anywhere, but only thing is the coordinates will change. Now I am taking y-axis from the center of semicircle. Now let us divide the given diagram into the known lines. So let us take the straight line as 1, semicircular arc as 2, and inclined line as 3. So let us solve this problem. So first let us calculate the centroid values for 1, 2, 3. Then by substituting all the values in the formula we will get centroid. So first I will write the centroid formula for the lines. So we know x bar equal to L1 x1 plus L2 x2 plus L3 x3, because there are 3 lines, 1, 2, 3. So I am writing formula for 3 divided by L1 plus L2 plus L3. So this is the formula for x centroid. Similarly, the formula for the y centroid, similarly we can write L1 y1, L2 y2, L3 y3 by L1 plus L2 plus L3. Now for x bar we will write all x values, and for y bar we will be writing all y values. So let us calculate all the values separately. So L1, that is length of the first line, that is given as 6 centimeters. Then we need x1. So x1 is the distance from center of the straight line up to the reference axis. I will show in the diagram. So this is the x1. So now to the left of y-axis we will be taking negative. So this value will be a negative value. So this x1 is minus 4 centimeters, because we know the radius of this. So this side its radius will be 4. So because it is to the left of y-axis we are taking negative, that is minus 4 centimeters. Now similarly y1. So y1 is the distance from center of line 1 up to the reference axis. So I will mark in the diagram. So this is the y. We know the total length of the line is 6 centimeters. So up to center it is half of the 6, that is 3 centimeters. So y1 is 3 centimeters. Now similarly let us calculate for the second diagram, that is L2. So L2 is the length of semicircular arc. So we know formula for the semicircular arc. So this is the semicircular arc given. Now what is the formula for total length of the semicircular arc? It is pi r. So I am writing pi r. So length of the semicircular arc is pi r. So that is pi into its radius given as 3. Sorry, it is 4. Now the total value of this L2 we are getting as 12.56 centimeters. Then x2. So this y-axis is passing through the center of this, so that x value will be 0. Then y2. So the formula for the semicircular arc along y direction, let us see the formulas. So we can see here this length is 2r by pi. So this is 2r by pi. So 2 into its radius is 4 by pi. So we are getting its value as 2.546 centimeters. Now similarly, let us calculate for the third line, that is this one. We know the length of the line L3, that is 8 centimeters. Then x3. So for the inclined lines, let us see the formulas. So we can see here, this is the inclined straight line. We know x bar equal to a by 2 cos theta, y bar equal to a by 2 sin theta. So let us take these values. So now we know the centroid formula, that is x bar for the lines. This is the y bar formula, and this is the L1, x1, y1. So we have calculated all the values. Now let us calculate the values for the third line, that is L3. So the length of the line given as 8 centimeters, and the x3. x3 means, so this is the center, you can see, and x3 means it is the distance up to y-axis. You can see here, this length is x3. But we know for the inclined line, this length is a by 2 cos theta, that is 8 by 2 cos 30 degrees, and this length is 4 centimeters. So now the total distance x3 is this length, that is 4 centimeters plus 8 by 2 cos 30. So let us write that value, 4 plus 8 by 2 cos 30. Now this value we will be getting by calculation as 7.46 centimeters. Now similarly, let us calculate y3. So y3 is the distance from center of the third line up to x-axis. So this is y3. This length is y3. So we know formula for this, that is directly 8 by 2 sin 30. So this is the y3 value. So let us write that value, 8 by 2 sin 30. So its value we are getting as 2 centimeters. Now substitute all the values in x bar, that is L1 x1 plus L2 x2 plus L3 x3 by L1 plus L2 plus L3. So substitute all these values here. So we have x1, y1, x2, y2, then x3, y3. So substituting all the values, we are getting x bar, y bar as x bar is 1.34 centimeters, then y bar we are getting as 2.4 centimeters. Now these are the answers. Answer is x bar comma y bar. So we are getting as 1.34 comma 2.4 centimeters. So this is the answer.